Hi, good morning. Today we are going to be doing right triangle problems. But before we start that, I sent this question to you. Actually, it was repeated twice on the page only because it's a half-page question. And you're not going to work the problem twice. You're only going to work it one time. This is such a great problem, and it deals with laws of exponents. So I want you to work this at your convenience and know that the answer you're going to get is 4. And if you don't get 4 out of this, text me on Remind and we will talk about it. It's a fabulous problem, so go get that. All right, right triangle problems. Here we go. Pretty basic stuff here. We're going to be working outside the unit circle right now, so you're going to need a calculator. And here's what we're going to go back and remind ourselves of. Definitions of trig. So, of course, we've got some angle theta. Opposite over r is sine. Cosine is adjacent over r, and tangent, of course, opposite over adjacent. And there's that SOHCAHTOA term again. That has never worked for me, but if that works for you, great. So here's what we know. We can solve right triangle problems just by having a little bit of information about the triangle. So as we're looking at this triangle here, we are looking for angle A, angle B, angle C. We're looking for segment AC, CB, and AB. So those are the 6 parts of the triangle that we need to have identified and figured out the values for. Well, clearly angle B is 25 degrees. Angle C is 90. And we know that there's 180 degrees in a triangle, so 90 minus 25. Angle A is 65 degrees. Easy enough. Now they've given me line segment AB, and they've told me it has a length of 14. So clearly I have 2 pieces of the triangle that I don't have yet, and that is segment AC and segment CB. So it's really up to you which one you want to find first. You're not going to work off the 90 ever. You're going to work off the other 2 angles. And since they gave me the 25-degree angle, I'm going to start there. And I'm looking for opposite, and I have hypotenuse. So what trig function brings in opposite and hypotenuse? I know that the sine of 25 degrees is segment AC divided by 14. So on your calculator, I'm almost reaching my phone. In your calculator, let's make sure we are in degrees. And I am. So 14 times the sine of 25 degrees is segment AC. So 14 sine 25. And segment AC is 5.916 units long. I'm sorry, I can't get all that on the screen. There we go. Now, you have 2 options here. You can use Pythagorean's theorem since you now have one of the side lengths. So let's say you wanted to do that. Let's say you said 5.916 squared plus CB squared is 14 squared. So 14 squared minus 5.916 squared gives us 161.009, and the square root of that, we have a length of 12.688 units. But you also have another way. You could have used trig for that. You could have said, wait a minute, I've got 25 degrees and I'm looking for the adjacent. So you could say the cosine of 25 degrees is CB over 14. So again, going to the calculator, 14 times the cosine of 25 and 12.688. So it doesn't matter what method you use, whatever's easiest for you, once you get to a certain point in the right triangle. All right. Now we're going to talk about angles of elevation and depression. So if you are standing, let's say you're standing here at the stop sign and you're looking up at this airplane, here's your angle of elevation. And they're basically opposite interior angles, and I don't want you to overthink this. The angle of depression, if I were to draw a horizontal here, and the pilot's looking down, he's looking down at you with the same angle. So let's just start out a little slow here. The altimeter of a jet approaching O'Hare Airport in Chicago is 5,900 feet as it passes directly over the Sears Tower. So I've got a Y value here. I have a height. At that point, this jet is 5,900 feet high. At the same time, the angle of depression from the plane to the end of the runway. So the pilot's looking down. Again, there's this imaginary horizon going out. He's looking down, and his angle of depression is 5 degrees. That means your angle of elevation is 5 degrees. The opposite interior angles, and don't ask me too much about that because I am really, really bad with the geometry, but that part I know. So, all right, how far is it from the base of the Sears Tower to the end of the runway? So the distance I'm looking for is here. So I've got an angle, I have an opposite height, and I'm looking for the adjacent height. So what trig function pulls in opposite and adjacent? Yes, it's tangent. So the tangent of 5 degrees is opposite over adjacent. And that's, of course, what we're looking for. So we're going to multiply both sides by adjacent and divide both sides by the tangent of 5. And these are not major angles, so of course you're not going to be expected to do these without a calculator. So here we go. We have 5,900 divided by the tangent of 5 degrees. I need 2 sets of parentheses. And I think we're dealing in feet. Yes. So we are 67,437.308 feet away from the end of the runway. So again, all trig, and they have to be right triangles for this to work. You can't do this on a different type of triangle. We'll get into that later. That's laws of sines and cosines. Okay. At 10 a.m., I don't know why the date's there, but a building 300 feet high. So I've got some building. Cast a shadow 50 feet long. So the sun's going to be up behind the building. What is the angle of elevation of the sun? So you're standing here and you're looking up at the sun, and this is what we're looking for. Okay, so again, I've got some unknown angle here. I've got an opposite height of 300, and I have an adjacent height of 50. So what trig identity, or trig equation, brings in opposite over adjacent? Well, the tangent of some angle is 300 divided by 50. So now, remember, you're going to be asking your calculator what angle has the tangent. Now you're doing your tan inverse. Okay. So what angle has the tangent of 6? And angles we round up. So we know that this angle of elevation is 81 degrees. All right. You must order rope for a flagpole. To find out what length of rope is needed, you observe that the pole casts a shadow 11.6 meters long on the ground. The angle of elevation of the sun is 36 degrees. So again, you're going to be drawing a right triangle. So I've got flagpole, sun behind it. There's a shadow. All right, we're looking for the rope for the flagpole, so we're looking for H. The pole casts a shadow, so here's my imaginary right triangle, 11.6 meters. The angle of elevation is 36 degrees. So again, I've got an opposite and an adjacent. So the tangent of 36 degrees is going to be the length of the rope divided by 11.6. So the length of the rope needs to be 8.427 meters. Long. Okay. Not a whole lot of magic going on here, and we're going to continue. Let's look at the assignment. Hang on just one second. Let me get organized over here real quick. It's my blank copy. Okay, so take out, well, it's 8:30, and it looks, hold on. All right, looks like this. We'll work through a couple of these together, and then we're going to go on to some more angles of elevation and depression. So, problem number one, these are all right triangles. Find the missing angles and the lengths. Round the angle measures to the nearest degree. It says to round to tenths, but we're going to go out 3 decimals. Excuse me, we're going to go out to thousandths. So, if this is 67 degrees, then 90 minus 67, angle A must be 23. Okay. Of course, that gives you 90. We're looking for length AB. AC has been provided. And we're looking for length BC. It's really up to you. Excuse me. I would use the angle they give you, because if you made a math mistake, let's just say you said this was 33 or 13 instead of 23, easy enough to do, then you're going to be thrown off. I would use the definitive angle that has been provided. And it's really up to you if you want to go after AB first or BC. I can either use opposite or I can use adjacent. All right, let's go with adjacent. So I'm looking for BC. So if I've got adjacent and hypotenuse, what do I have? I have cosine. And the cosine is going to be segment BC over 15. All right. But let's say that you had, well, no, let's just stick there. Okay, so I have 15 cosine 67. So you should have a length of, for BC, 5.860. And if you had chosen instead to look for the opposite, you would have used sine, and that would be AB over 15. So 15 sine 67 gives you a length of 13.807. Let's just say when you had found BC, 5.860, you had decided at that point you wanted to use Pythagorean's theorem. That's fine. There's not a problem with that. So you would have said AB squared plus 5.860 squared is 15 squared. don't know if I can get this on the screen at the same time. Okay. Excuse me. So 13,807. So it doesn't matter which way you go, whatever you're comfortable with. Okay. Problem 2, a little different, because now I have length AB, length BC, and I only have one angle measure, and of course it's angle B, which is 90 degrees. So I've got to find the other two angles, and I have to find the length of the hypotenuse. So right now, I'm limited to finding either angle A or angle C. I think I'll go after angle C first. So I've got opposite and adjacent. Excuse me. So the tangent of some angle is opposite over adjacent. The tangent of some angle, angle C, opposite over adjacent. So now again, remember, this is a tan inverse problem. What angle has the tangent? 22 divided by 14.7. And you've got 56 degrees. Well, now you don't have to use trig anymore. You know that angle C is 56 degrees, so 90 minus 56, angle A is 34 degrees. You have AB, excuse me, you have BC, and it's up to you if you want to use Pythagorean's theorem, or you could use either sine or cosine. It doesn't make any difference. I've got that 56 degrees. I'm going to stick with that, and I'm going to say the sine of 56 degrees is opposite over hypotenuse. Okay, so the length of AC is going to be 22 divided by the sine of 56. We're multiplying both sides by length AC, and we're dividing both sides by sine 56. So 22 divided by the sine of 56 degrees, we get a length of 26.536. And again, if you had decided to use Pythagorean's theorem, a square plus b square, and the square root, of course, is 26. We're off just a little bit, but I wouldn't worry too much about that because you're talking about tenths of a point. It's just rounding at that point where your calculator's rounding. All right, let's do one more. We've got a length and we have an angle. Again, they provided the 39 degrees. So I know that angle A is going to be 51 degrees. 50, 80, 90, that adds up to 90. AB is 23. So now I want to find BC. So I know that the tangent of 39 degrees is opposite over adjacent. The tangent of 39 degrees, opposite over adjacent. So the length of BC is 23 divided by the tangent of 39. So I've got 28.402. And at this time, I think I'm just going to go straight into Pythagorean's theorem. I'm going to square that. I'm going to add 23 squared to it. And I'm going to take the square root, of course. And I've got 36.547 as my length of AC. All right, let me give you some answers to the back. Well, I think they're included in the packet I sent you. So if you have trouble getting to those answers, let me know and I will see if I can help you. Again, text over remind with that and we'll go from there. The right triangles are really not so bad until we start getting into the real world applications of them. Yeah, I did. I texted you the key or scanned you the key. All right, here we go. We're going to move on to angles of elevation and depression and my beautiful artwork here. An angle of elevation is formed between a horizontal line, the horizon, and the line of sight. Right, as you're looking up at something, that is your angle of elevation. And the angle of depression is the horizontal line. You're generally going to have to draw that yourself, and the line of sight to the object below. Okay, they're opposite interior angles. They are the same. All right, here we go. A 98-foot extension ladder rests on top of a hook and ladder truck with its base 11 feet from the ground. When the angle of elevation of the ladder is 73 degrees, and it's drawn in there for you, how high up the building will the ladder reach? So what we're going to do, we're looking for this. This is our problem right here. So I've got opposite and I've got a hypotenuse. Sine of 73 is opposite over hypotenuse. So the ladder will reach 93.717 feet. And don't forget, the hook and ladder truck bumps it up 11 feet off the ground. So we're going to add that to it. So I've got 104.717 feet that the ladder will go above the ground. Okay. Determine an airplane's altimeter reading, the height of the airplane. If an angle of depression to the runway is 40 degrees when the plane is 12 miles from the runway. So the first thing you have to do is draw your right triangle. I've got an airplane. He has some height from the ground. There is a runway here that he's going to be landing. And of course, he's looking down to the runway. So what do we know? The angle of depression, remember that your imaginary horizon is 40 degrees, which means my angle of elevation is 40 degrees. The plane is 12 miles from the runway, and we're looking for the height. So think about what you have coming off this right triangle that you've drawn. You have opposite and adjacent. So what trig function brings in opposite and adjacent? The tangent of 40 degrees is the height divided by the miles. So 12 tan 40. The height of the plane is 10.06 miles. At this point, when you're dealing with real world problems, I would get used to putting the units. And if you're moving to calculus, definitely get used to putting the units. Shockingly, you get a point on your questions from units. You have to earn the point, and we'll talk about that next year, but just get in the habit. Okay. A stranded boater tries to gain the attention of a rescue helicopter that is 30 feet away. The helicopter is hovering at 70 feet. What is the angle of depression, which just means what? The angle of elevation from the pilot to the boater. So I've got this stranded boater. I guess he balances on one foot or something. Here, let me make his hair stand on end because he's panicked. Okay. 30 feet from him is a helicopter. That's a pretty good helicopter. I think I'm missing something, but oh, how about a rotor off the back? Yeah, well, good enough. The helicopter is at 70 feet. What is the angle of depression? Which means what? The angle of elevation. That's what we're looking for. So again, I've got an opposite and I have an adjacent. So the tangent of some angle is 7/3 or 70/30. It doesn't make any difference. So again, remember, this is an inverse problem. What angle has the tangent? 7/3. And that angle is going to be 66.8, so it is rounded up to 67 degrees. Clearly not drawn to scale, but that's okay. Because if anything, this looks like you're 23 and that looks like you're 67, but that's not the issue. No points for the drawings. Okay, a tower with a height of 45 meters is 25 meters from point A. Okay, so I've got some tower, 45 meters. It has some radio on top. We are standing over here at point A. Again, not to scale. And we're 25 meters away from it. Find the angle of elevation. So you're looking up to the top of the tower. So I'm looking for this angle here, just as we were in the previous problem. What angle has a tangent 45 divided by 25? And we are at 61 degrees. Okay. All right, here we go. The angle of depression of an airplane to the airport is 30.1 degrees. If the angle of depression is 30.1, what's the angle of elevation? 30.1. You always make us do our angles our degrees. I know, just go with the problem. All right, so again, I've got an airplane. The plane is 10.3 kilometers kilometers from the airport. So here we are. Determine the altimeter, the height inside the plane. And we have an angle of depression of 30.1, which means we have an angle of elevation of 30.1. I have an angle, I need opposite, and I have adjacent. The tangent of 30.1 degrees is the altimeter reading divided by 10.3 kilometers. .3 times the tangent of 30.1. So the height of the airplane is 5.970 kilometers. If you want to round that up to 971, that is fine with me. It doesn't make any difference. Okay? All right. So let's move on to this worksheet of right triangle problems. There is you'll notice it says use trig to solve the problem, so you're either going to be using cosine, sine, or tangent. And we're going to start with leaning a ladder against a wall. It makes an angle of 63 degrees with the ground. How high up is the top of the ladder? Now they're talking about from the ground. So you've got, again, you're going to be drawing the right triangle. You have a wall here. we're leaning this ladder up against it. And the ladder is 6.7 meters long. So that's my hypotenuse. We have an angle of 63 degrees with the ground, not with the wall, with the ground. And we're looking for how high up the wall the ladder is. So I've got an angle. I have opposite and hypotenuse. What trig function brings in opposite and hypotenuse? The sine of 63 degrees is the height up the wall divided by the length of the ladder. So 6.7 times the sine of 63, the ladder is 5.969 meters from the ground. Okay, let's go on to 3. This one's a little tricky, but not too bad. From a point on the north rim of the Grand Canyon, a surveyor is measuring an angle of depression of 1.3 degrees to the south rim. So I've got a surveyor. It's hot, so he's wearing a hat, I'm sure. Probably a top hat. And he's up here on the north rim, and he's measuring an angle of depression. And that angle of depression is 1.3 degrees to the south rim. So some spot down here. Okay, if that's my angle of depression, it means what? From the south rim to him, well, that was a terrible straight line. From the south rim to him, we have an angle of elevation of 1.3 degrees. From an aerial photograph, he determines that the horizontal distance, remember horizontal distance, from the 2 points is 10 miles. So here I have 10 miles. How many feet is the south rim below the north rim? So we're looking for this height here in feet. I meant to ask you this earlier. How many feet in a mile? I meant to ask you that when we were doing the other problems. All right, look that up real quick. You should have 5,280 feet in a mile. Okay, so I've got this angle of 1.3. I'm looking for opposite, and I have adjacent. This sounds very, very familiar. So the tangent of 1.3 degrees is the height over 10 miles. 10 times the tangent of 1.3 degrees is 0.226 of a mile. Remember, we're in miles right now, right? So I'm sorry, there's an ambulance going by and it's been so quiet for so long, it's hard to, it's just hard to think that through for a minute. It's like, oh, that's kind of weird. All right, so we're going to multiply that by feet. We're a quarter of a mile, so 5286. We are 1,198.199 feet above, or basically a quarter of a mile, just shy of a quarter of a mile. Let me give you the answer to problem 3. Problem 3, your angle measure will be 76 degrees. All right. Let's look at problem 4. An observer 80 feet above the surface of the water measures an angle of depression 0.7 degrees to a distant ship. How many miles is the ship from the base of the lighthouse? So I've got a guy standing up here. I think it's the same guy that was the surveyor. Got a little broader brim of a hat this time. He's 80 feet above the surface of the water. And he sees a ship out here. And his angle of depression is 0.7 degrees, which means if I draw an angle of elevation from the ship to him, it's going to be 0.7 degrees. How many miles is the ship from the base of the lighthouse? I'm sorry. So the problem says the observer's 80 feet above the water, and then all of a sudden it says lighthouse. I should have drawn a lighthouse. He's inside the lighthouse looking at this. So we're looking for this distance. So I have an angle, an opposite, and a hypotenuse. Adjacent. So again, the tangent of 0.7 degrees is 80 over h, or length, I guess we want to say here. So the length of the ship, or the distance of the ship from the lighthouse at 80 feet is going to be 80 over 10, 70. 80 feet is what we're dealing in. So I've got 80 divided by the tangent of 0.7 degrees. I know that, again, we're in feet. We are 6,547.763 feet away, because we started in feet. He was 80 feet above the water. So we're just going to divide this by 5,280, and we get 1.240 miles away. All right. Our next problem. Commercial airliners fly at an altitude of about 10 kilometers. They start descending from the airport when they're far away so that they don't have to dive at a steep angle. The pilot wants to make an angle of 3 degrees with the ground. At what horizontal distance must he start descending? So again, I've got this pilot. He's coming in for his landing, and he wants a 3-degree angle. We know that he is 10 kilometers in the air. So at what distance, must she start descending? So again, I've got an opposite and adjacent. So the tangent of 3 degrees is 10 over, I don't know is 10 divided by the tangent of 3 degrees. Okay, so at 190.811 kilometers is when he should start descending. All right, part B. But the pilot decides to start descending at a ground distance of 300 kilometers from the airport. So now what will the angle be? Well, think that through for just a minute. If he's going to, or she, excuse me, is descending at 190 kilometers and has a 3-degree angle, right? So if the descension starts at 300 kilometers, then our angle is going to decrease. So whatever answer we get should be less than 3 degrees. So now we've got the same scenario. But now we know we have 10 kilometers here, and we're going to be 300 kilometers here. So now we're looking for the angle measure. So again, opposite and adjacent, the tangent of some angle is 10 over 300. So you're using your inverse here. What angle has the tangent? Second tan. Oops, sorry. Hold on just a minute, I just fuzzed that up. So what angle has the tangent? 10 divided by 300. And we have 1.909 degrees. And if we are to round it to whole angles, then theta is 2 degrees. And that makes sense, because the dissension's starting farther out, which means your angle is going to be lower. All right. I think that's all the problems we have there. And that should finish. Well, you know what? I've got 4 minutes left. So let's go ahead and just work the cat problem. I gave you the answer already, but let's just go ahead and work this. The cat is trapped on a tree branch. So I've got a tree. And there's the branch. And I've got this cat trapped there. That's my cat. And the branch is 6.5 meters above the ground. So clearly, we know that this is 6.5. You're going to be standing over here, trying to help your cat. And you've got a ladder. And you're trying to reach this cat. And your ladder is 6.7 meters. What angle should you use? Well, now I have opposite and I have hypotenuse. The sine of whatever angle I'm making this ladder with the ground is going to be opposite over hypotenuse. So now again, you've got an inverse problem here. What angle has this sine? And there you go. 75.96, or theta is 76 degrees. Okay, that should take us out. If you have any questions on any of those, just text me on Remind and I'll try and answer them for you. But you have the keys and you should be able to work yourself through them. Thank you guys, you've been great. See you next time.